before we write any code, I want you guys to be aware of a couple things that you're going to see in every, and I say 99.9% of C programs out there. First of all, this you will see in IDEs. When you're creating a project, your IDE, sometimes we write this metadata or this data here just to signify that you are in that file, that's the name of the file, and so on. Now, in every C program, you're going to see something like this, and that's because they're very useful. This is a inclusion of the libraries of C, of every C program out there. This is the standard input and output. You can see that is stdio, input and output library, and this is the standard library. Okay, now we're using this code here, this pound symbol include space less than symbol, the stdio.h, and then the greater than symbol. That's basically letting us know that this is the core C files. These are core C files that we are including here. That is what this less than and greater than symbol is. Okay, so we are including two core libraries or files from the C language. Most of the time, this is going to be pulling it from your computer, from wherever you are, right? So every time I click build somewhere in this IDE, it's going to create binaries, okay, zeros and ones, so your computer can understand this. So basically, it's going to compile our code. It's going to take all these tests and make it into binaries, all right? If you click on binaries, you're going to see something weird, right? That's because this editor is not going to translate for us these things, but you can see all these weird symbols, all right? It's in there, okay? If you have a binary, sorry about that, this binary reader, you can translate some of this code, all right? But anyway, or a converter, right? A compiler that you can find online, binary conversions and things like that. You can play a little bit around with it. But anyway, so once you build it, and we can do that by going here and build all, you're gonna build those binaries, okay? So anyway, and that's going, and this here, these are called pre-directives. Basically, pre-directives is code that it's actually included or working before it's compiled, all right? So we are including all these libraries before it's compiled. Then once it compiles, the operating system is going to be looking for this main function, okay? But anyway, so this hash include space and this words inside this less than and greater than symbols are libraries. This is the main function of every C program out there. Okay, so every C program has to have this main function. This int is just signifying like it's an integer type of function. Don't worry too much about this. You know, we'll probably touch on this later on. But just keep in mind that this is the main function. Void is just, you know, that it doesn't take parameters. Don't worry too much about these little things out there, but just know that this main function is what we need in order to run a C program. These functions that you're going to see here, like put or printf and some of this pre-built stuff, remember that they're coming from the standard library, okay? That's where they're coming from. And that's the pre-built code that we use to write programs in C. If we didn't have that, we would have to write a lot of stuff, and that would just make things very hard to do and very lengthy, okay? So anyway, that's one of the things that I wanted you guys to know. Another thing is that we also, just like in any other programming language, we can write comments. / twice is a single comment, and / asterisk is a multi-line. And you can tell because I keep writing and writing and writing. All right. And the asterisk with a / after it is just signifying that it's over. All right. That the comment is over. So if I take this off, you can see that it comments everything below. It's just like other programming languages. So single line and multi-line comment. Perfect. All right. That's all I wanted to show you here in this lecture. Thank you so much, and I'll see you in the next one. Welcome, my awesome students. So on this lecture, I want to show you how to create custom files that you can include, or how to include custom files into your project or program. Okay, so we talked a little bit about this, right? I told you that these were libraries that we are importing. So to import a custom file, all you have to do is do something very similar than what we're doing here. Okay, so we could do something like this: hash symbol or pound symbol, right? And then quotes, and then the name of the file. Okay, something like this. No semicolon or anything. This is a pre-directive, basically a command or some type of, well, it is a command that we are, letting our program know, or in this case, the operating system. I want you to include this before you compile anything. And then once you compile, then look for this main function. Those things are the process that it takes, okay, the steps. So, we have a file that we need to create. So I'm going to go to source, and right here, I'm going to create a file. I'm going to say customer.h, and H, the .h stands for header file, right? As a matter of fact, we have it right here. Inside includes, and by default, your C program is going to be looking in this folder here when you have header files. But we can also put it in the same level as, as our project. In this case, right here in the source folder. Okay, and that's it. Now you're able to pull the information from that file and use it here, like like you're writing the information here. So how do we export that information? Well, let's go back to the customer.h. Here, what I'm going to do is I'm going to define a constant, okay, and we can use that using pre-directives. Okay, so let's and the pre-directive means, that something's happening before it's processed. It's pre-processed, all right? So we use the pound symbol or number symbol, if you want to call it that. We write the name of that directive, or in this case, a constant, because this value will never change. We cannot change this value later on, okay? So I'm just going to put name, and actually we don't need that assignment operator here. We do everything by using spaces here, okay? And this is a string. If I wanted a number, I would write the number without the quotes, okay? So right here, I want to actually output this. So I'm going to use another function that will allow me to do this very easily. I'm going to be using printf, and with printf, I can write some strings here. Hello. And I'm going to put a placeholder here. And basically, this is how you replace some of the string values here with a variable. You create we use a format specifier. We're going to see that later on, but there are many of them. And we just have to do % and the data type. In this case, it's going to be a string. And then in that second parameter of this function, pre-built function that's brought out to us by the libraries that we have on top. Right here on the second parameter, I write the name, okay, of that value that I want, and this is the name of that value. So I'm going to save the file. Remember to save it. So go to File, Save, or Command S if you're on a Mac, or Control S if you're on Windows. I'm going to save this one as well. Okay. So now my underline, that red underline that was there, is gone. You can see now that something is happening here. Now, I'm going to clear this out, and I'm going to play it, and you can see that it says, hello, Edwin, okay? Right there. Remember, this is getting compiled automatically if you go to project, and you can see that there. But if it's giving you some type of error, make sure you save your files, and then build old, and then play it or run it, all right? And that's all I wanted to show you on this lecture. Thank you so much, and I'll see you on the next one, guys. Take care. Hi guys, this is Edwin Diaz. Welcome again. So in this lecture, I want to show you something before we keep going, all right? So there is something very important that happens in the C programming language, and that has to do with data types. That's something that is actually going to follow you in your whole C programming career, or phase that you're going through right now, right? And I say phase because a lot of us jump into a language and then we jump into another one. We stay with other languages instead of the first one, right? So anyway, in C, we manage memory with data types. All right, there are ways that we can limit certain things to happen in our programs with the type of data types that we use. For example, if I am writing something very small, like like I'm writing a program for some calculations that are not gonna go over 1,000 or something like that, or even less than that, maybe 200 or something like that, or a 10 or 20, whatever. Then I will use something like float, like int. I'm sorry. This would be the int data type. Excuse me. Float would be used for decimal values. For example, like if you have a number that's 1.5, 1.6, to anything that has a dot or a point and some other numbers after it, that we consider to be a float number. And then we have the double float, which is double this guy. And it says double precision here because the precision, the data type that this one is more precise than float. So when it's rounding numbers, then this here will give you more memory, will use more memory, and at the same time your numbers will be more precise because it can save more numbers. So if you have a really long number like 3 billion and a lot of other numbers, 3 billion and 500 million and 625 and some cents, this would be a really good data type to use instead of this one. Okay, now if we go down a little bit, we can see that each data type has something called, well, first of all, we can see the bytes that each of those take in memory. And at the same time, we can see something here called a format specifier. Okay, these are basically the placeholders in a way that we use for each of this data type. Okay, so you're going to see me using it right now because I'm going to give you an example how you can find out each of these bytes, each of these data type bytes or measurement. Okay, remember that bits and bytes, megabytes, gigabytes is a measurement of memory in your computer. So let's go back here. I'm going to comment this out real quick and I'm going to use the printf function again. I'm going to write a string here. I'm going to say that data type char has a measurement of I'm just gonna come here and I'm just gonna say size of. That's the function I want to use, and then here I'm just gonna put char. Okay, and this can look very familiar to people that come from JavaScript, right? Anyway, so let's save this and let's run it, and you can see that we don't have anything here, and that's because we need to use a format specifier. I'm gonna use here, I can use whatever I want that's related to my data type. I'm gonna use something like LU, okay? And if I save it and I run it, you can see that it says one here. That's for 1 byte. Okay, of course you can do the rest. Okay, you can go ahead and play around with other data types like long or short or int. Just get to know them if you like. Like I mentioned before, one of the most common ones are char, int, float, and double. Okay, to use anything other than that, you will have to be very experienced and you will have to know what you're doing. With time, you will get into those data types. Unless you already come from other programming languages and you have some experience with data types, then you go ahead. These are the data types for C. And there are a couple more. You also have the format specifier. Okay. So as you can see, there's an example here. For an int, we have the number 1. For chart, we have quotes. And for double, here you have a decimal point, 3.14. Okay, super simple. So you can go ahead and play a little more with data types. I'm not going to give you more examples here. I'm going to finish this video, and then on the next lecture we're going to continue. We're learning about variables, arrays, and loops, and other things that we need to learn how to do in C, which is very similar than in other programming languages. See you in the next lecture, guys. Take care. Hi, guys. So in this lecture, what we're going to be doing is actually, giving you an example of format specifiers, just because I already, explain a little bit about them, but there is a little bit more to them, so that way, you can use them efficiently. So let's put a comment here. I'm just going to say format specifier. I believe specifier just like that. And I'm going to be using a printf function again. Okay. And I'm going to that file that we created. I'm going to create another constant here. Let's call it that, right? And it's going to be a number. I'm just going to put 3.14. Okay. Save it. Let's come back here. I'm just going to say this number is pi, for example. Remember that we need a format specifier there. I'm just going to put number here, but we need a specifier. I'm going to be using %lu, okay? And you can go back to that page and you can look at it. lu right here. Well, that's 2 L's. This one is unsigned long int, okay? Well, you know what? Let's just make it a float, because if we go back here, you can see that that's a float number, right? So my format specifier is going to be a float. Now, if I build this, you can see now that if I run this, you can see that it says 3.140000. Okay, we have 6 spaces by default. We have 6 spaces there. Now we can limit the spaces by doing .3 or 0.3, and that would just, let the program know, hey, listen, I just want 3 spaces there. I want 1, 4, and 0. If I do 2, then we give me 2. So let's go ahead and run it, and you can see now it says 3.14. Okay, awesome. Now we can go back here and we can create a second number. Let's just call this, it's not going to be a number, it's going to be another constant, street. I'm just going to put a string here. I'm just going to say Avenue H, because I used to live in Brooklyn. And I'm going to pass a second parameter here, okay? But first, know that each of these parameters is going to be equal to a format specifier in here. So I'm going to put a space, and I'm going to do %, and it's going to be a string, so I'm going to put an S. And then here, I'm going to put another parameter, and that's going to be my constant, right? My directive value, or my directive. So as you can see now, each of these placeholders in order applies to this here. Okay, if you switch this around, you're going to get an error, because street has a value that is a string, not a float. And we have a float here for that number 1 spot, right? So if I run this, you can see now that it says pi 3.14 Avenue H. Okay, so that's what I wanted to show you about format specifier. We jumped into a little bit more, we got a little bit more knowledge out of this lecture for format specifier. You don't need much of it, but you need this at least to start coding in the C programming language. Anyway, thank you so much, and I'll see you in the next lecture, guys. Take care.